Some properties of vectors. So we already know that they have a magnitude and direction to be a vector. Now, if they have the same magnitude and same direction, we call those vectors equal. Notice that they don't have to have the same starting point. This is one of the powerful things about vectors, is vectors does math without worrying about where you started and where you ended. Just how far you're going, what direction you have, and what length that you have. So even though those two vectors have different starting points, we call them equal vectors. Negative vectors or opposite vectors have the same magnitude but the exact opposite direction. Again, the starting and the ending point don't matter, but as long as the direction is the same but in opposite ways, and they have the same length, they're called negative vectors. And if you multiply a vector by a scalar, by a certain amount, it increases its magnitude, and those vectors will always be parallel, just one will be longer than the other. So what we have to find out is if two vectors are parallel, one will be a multiple of the other one. If we look at these, if we actually figure them out, our first vector from A to B is 4, 5. Our second vector from D to E is 8, 10. And we can just show that D to E is 2 times A to B. And so in a sense, what you're doing with this 8, 10 is you're factoring out a 2 out of each of the coordinates. Oh, too fast? Should I go back? So what we have here is we are going to look and use A and B as our main vectors. And you're going to write all of the other vectors in terms of A and B. So first of all, there we have A and B. A is 2, 4. B is 2, negative 1. C is negative 6, 3. And if you factor out a negative 3, you get vector B. So we can say that vector C is the same as negative 3b. So that's the idea. Continue with D, E, and F. You can check how you did. So for vector D, noticing that it's half of vector A. Finally, part B, how are A and B related? Well, the slope of vector A is 2. The slope of vector B is negative 1/2. That means that they're perpendicular. And here we have a new word for perpendicular that we're going to use a fair bit in this unit, orthogonal. Have you heard that word before? I guess it's because it's so close to perpendicular. Because when you first learned the word perpendicular, you had never heard that before and it seemed like the weirdest word in the world. So now we're introducing you to the word orthogonal, which is a word you've never heard of and seems like the weirdest word in the world. So they're perfectly the same. So 7i plus j you can write as a column vector. 7 over 1. And that would mean it has a slope of 1 over 7. So again, every time we have a column vector, it's really just the flip of the slope, because you have the x on the top and the y on the bottom, where slope is rise over run, which is your y on the top and your x on the bottom. Now, in order to show that two vectors are parallel, you just need to show that a vector is a multiple of 7, 1. So you could figure out the slope of this one, and that would be one way of showing it. Or you could just factor out the negative 1, and that would be another way of showing that it's parallel. But it probably makes a lot of sense just to figure out the slopes. And that's doing your rise over run, which is your y over your x. So you can do that with each of these. So the second one will be the same. The third one has the 1/7, but it's negative. So it's not going to be parallel. So here we have two vectors. We want them to be parallel. Vector r is 8i plus tj. And vector s is 20i minus 16j. So what we know is if they're parallel, the one vector will equal the other vector multiplied by some scalar. That's the idea that we've seen before. If we write both of these as column vectors, that's what this would mean. Can you find a k value that would make this work? Well, if you multiply that k through, you might say to yourself, well, does it make sense that this would have to equal this? And so if we set that up as a little minor equation, we can find out what the k value would have to be. In this case, it would have to be 2/5. So we're going to need to divide by 5 and then multiply by 2. We can now use that idea and solve for t. We know that k has to be 2/5, so t would have to be negative 32 over 5. Sometimes in these questions, the numbers will be so easy that you can just see it. But it's important to do questions like this one where that k value of 2/5 isn't something that comes out naturally. So you can see how you can use the algebra to help you solve that. So I'd like you to try the last question. That's where we're going to end today. Example 4. Put up the first little bit to see if you set up things basically the same way. And if you are able to solve that k has to be a -5, which comes out pretty obviously. You might have even been able to just see it from right here, right? You need this to be a -5. That second coordinate is the only thing that's going to help you figure that out. And then once you got k is -5, you can find both t and s.